Right, there's question one, and we are actually just beginning question one, but I want us to look at the basics and build up to more advanced. I want you to work on the trials, actually, because the trials are out. 1.1. Right, so looking at 1.1 right now, we are dealing with solving for x, and I know that this is a very, very basic concept that you know very well. Right, so we are getting started. How do you solve for x given something so simple? Oh, you need to write notes at the end of the discussion, right? So the factors of these are very obvious, right? You can easily write the factors of this expression. So the factors of x squared, for instance, we know already those are x and x, all right? And obviously we know that this is -5 and this is +4. When you multiply them, they give you -20. When you add them, you get -1. And that means x is 5 or x equals -4, okay? So and these are actually the solutions to this question. All right, the next thing we're going to do right now is to look at the next question, 1.1.2. So once again, you just have to focus, and you don't need to write anything here in terms of notes at the moment, and you write during your own spare time. Please write down the notes during your own spare time. X equals minus b, and you have b squared minus 4ac, and this is all divided by twice a, and this is minus into -2 plus or minus the square root of, right, the b is -2, you square it, -4, the a is this one here, right, the a is 3, and the c is -6, okay, and you divide everything by twice a, and a is actually 3, right? And we continue to simplify this, right? And we can easily simplify this expression. So what we're getting, therefore, is that we have 2 plus or minus the square root of what is under, obviously, the radical sign, and 2 by 3 is actually 6. And now moving forward, we need to just deal with what is under the square root, so we can use our calculator to deal with what is under the square root. And now what is under the square root will give us the result, okay? And so we have 4, and 4 by 3 is 12, and 12 by 6 can be determined using a calculator, and obviously we can use our own ability to multiply those. So, right, we are exactly here right now. Okay, we are here. Right, so what is the result under the square root? Let's just do that quickly. So you have 4, right, -2 squared is 4 plus, and then you have 12 by 6. Right, so what we're getting under the square root, we're getting 76, and it's out of 4. Right, yeah, it's all out of 6, everything, okay? Right, so with that said, the question then is, what is then the result at the end of this? 76 is the same as what? Is the same as 2 by 38, so it's 4 by 17. So you can write this as 2 plus or minus 4 by 17. Okay, you divide everything by 6, which is 2 plus or minus the square root of 4, the square root of 17, all out of 6. And therefore, this is 2 plus or minus. The square root of 4 is what? It's exactly 2. And then the square root of 17. Please, you need to write down the notes from this in GF6. And during the week, we need to discuss a lot. We need to, please, on Wednesday evening, we need to have our discussion, please. And you have this, you divide 6 by 2, you get 3. So the conclusion, therefore, is that we have 1 plus the square root of 17 divided by 3, or x equals 1 minus the square root of 17 divided by 3. And therefore, that is the result, but we can be in a position to simplify this and get the result required. So we shall get what? We shall get the decimals out of this. So we could use our calculator to get the actual decimals. So we're saying x is approximately that, and we are saying y is approximately that. So in the end, we have the following, right? So what we then have is that x is approximately what, and y is approximately what? Okay, 1 plus the square root of 17, you divide everything by all divided by 3 there, and the result is what? Okay, this one here is actually 4 by 19. It's 4 by 19. Right, so 4 by 19. Okay. Okay, so just watch out this one. Okay, so this one here is actually 4 by 19. Just a sec. Written something else here. Right, so it is actually 4 by 19. Not 17, but 19 here. Right, so it is 19 here. Right, so I'm just putting 19 now. So it's 19. On Wednesdays, please, we need to step up. We need to have evening programs. Right, so now we have 1 plus the square root of 19. And therefore, what is 1 plus the square root of 19? It is 1.79. And therefore, this is minus 1.12. And that's the answer to this one. Right, so we're done with this one, and we have solved it to actually the instruction because we need to do it to 2 decimal places. It has been the case with exams. Now we have 1.1.3. We need to solve this one. We square both sides of this, so this is the by implication, and therefore this is exactly x squared. You square x minus 2x plus 1. You bring across, you transpose the 9, making it negative, and therefore this is x squared minus 2x. 1 minus 9 is minus 8. Okay. And therefore, what is this here? Right. So you have the factors of this. You can you have a quadratic expression. So this one is quadratic. Right. It's a quadratic inequality. So it's minus 4 plus 2. Okay, so there are a couple of things to look at here, and we look at the critical values. Which means x is 4 or x is minus 2. Right, and so now the couple of ways to do this, what you do is this resembles a parabola. So you have minus 2, 4, x. Right, so at this point, you have the answers, but now this is greater than 0. So greater than 0 would mean you, okay, because it's not equal to 0, so you put an open circle on the x-axis. Because it's not equal to 0, put an open circle and you go up like this, and you go up like that. So now, if we're saying it's greater than 0, what we mean therefore is that x must be less than minus 2 or x is bigger than 4. Okay. Right, so we have exactly that one. So that's 1.1.3. All right, now the next thing is now we solve this one. This one obviously is a sort of a radical equation. Right, so it is actually a radical equation. So this radical equation can be solved. Radical equation. Okay, this can be solved with ease. So you have 2 into x plus 6, which is x minus 2. which means 2 into x plus 6. X minus 2, which is x plus 6. And then it is exactly x squared minus 4x plus 4. Right, so you multiply through and you have 4x plus 24 equals x squared minus 4x plus 4, which means you have x squared minus 8x, x squared minus 8x minus 20. So we have this here. So you have this one here is minus 10 and 2. So we have x equals 10, or x equals minus 2. Okay, clearly if you put minus 2 into this, you need to substitute into the original. But x is not equal to this and x is this. Okay, you need to check by substituting to the original, but on the right-hand side, you'll get x minus 2 and then you plug in the minus 2. X is minus 2, so you have minus 2, which is minus 4. You look at the left-hand side. The left-hand side is 2 into the square root of x plus 6, which is 2 into x is minus 2 plus 6. Right, minus 2 plus 6 is square root of 4. Square root of 4 is 2. Okay. Now look at this very carefully and think. Okay, but there's a 2 in front here. Another 2 here. So you have 2 by 2, which is exactly 4. Okay, the fact that now the left-hand side is not the same as the right-hand side. Okay, because you can see that the right is minus 4. The left is 4 and the right is minus 4. So they're not equal to each other. So that's why this x minus 2 is actually inadmissible. Right, it is inadmissible. Okay, if it is inadmissible, then we have the next thing to do. Right, so we have that x equals to 10 is the only solution in this radical equation. Now we continue to look at the next one. We need to solve simultaneously for x and y. Right, to solve simultaneously for x and y, we can call this one for x plus y equals to 2, equation 1. For x plus y squared equals 8, equation 2. And then you have y equals minus 4x plus 2, equation 3. Right, so you have then 4x plus, what is y, is minus 4x plus 2, equals 8. Which means you have 4x plus 16, x squared minus, okay, the next thing is you say minus 4x times 2, minus 8x. Minus 8x times 2, minus 16x. You square 2, you get 4, equals 8. And this is exactly 16x squared minus 20x. 16x squared minus 20x minus 4 equals 0. 16x squared minus 20x minus 4 equals 0. Okay, so we have this simultaneous equation. So what we're then getting out of this is we have exactly this one. No, there's a small typo here. Okay, here you need to change this one. It is exactly 4x minus 16. What is 4x minus 16? Minus 12. Divide through by 4. Divide through by 4. Right, they are factors of this here. So you have 4x and x, and then here you have x minus 1, x plus 1. I know you can do factorization. On Wednesdays, I said already, we need to plan, please. Wednesday evenings. Doesn't have to be during the day, okay? Because my fear is that time is not on our side. Right, so we have to divide the board that way. And after having divided the board that way, we are in a position to continue. All right, we're in a position to certainly continue there. If we continue, we have y. What is y? X is minus 1/4 plus 2. Oh, this is minus x equals 1. So this is 3 minus 2. Okay, so these are the answers. So in other words, you have the solutions which are points. When x is minus 1/4, y is 3. When x is 1, y is minus 2. So these are the solutions to that, to the simultaneous equations. Okay, simultaneous equations. Right, so we continue. Right, in 1.3 now, we want to solve the following, and we're given an equation. Right, so given this equation, we proceed as follows. Right, so we have 2 to the power x, 3 to the y, 24 to the power 6. Right, want to find the difference of x and y. Want to find the difference of x and y. And therefore, now to calculate the numerical value of x minus y, we need to manipulate this equation here. So what we can do first things first is to deal with 24. What is the number 24 the same as? Right, 24 is the same as 8 by 3. 8 times 3 is the number 24, and then 8 is 2 cubed. And therefore, it is 2 to the 18. Which means it is 2 to the x times 3 to the y. Which means it's x to the 18 and y 6. Y equals 6. Okay. Now, as a consequence, what we're getting is the following. The conclusion, therefore, is that the difference we need to get now, we need to subtract this. X minus y. So x is 18 and y is 6, and the difference is what? The difference is exactly 12. So that's what they wanted. So they wanted us to get x minus y, obviously given that expression there, and we're able to see that given that expression, we can be able to determine the numerical value of x minus y. So x minus y is 12. X minus y is 12. Right, we continue to look at question 2, and now question 2 is about quadratic sequences and the things that go with the quadratic sequences. So now, the first question is that given the quadratic sequence with the terms 72, 100, and 120, with 132, determine the value of t and the nth term of the sequence. So what this emanates is that, so you have 72, 100, 120, 132. And now we can get the difference here. 100 minus 72 is 28. 120 minus 100 is 20. 132 minus 120 is 12. 20 minus 28 is minus 8. 12 minus 20 is minus 8. This observation is enough for us to say then 2a is equal to, so here we can come and write this. Here we can come and write 2a equals this. We write 3a plus b equals 28. And then we write a plus b plus c equals 72. So yeah, we have this. Wednesday evenings, if you're busy during the day, we can use those, please, to do more work. We need to just step up now. 2 or more days every week. So which means that 2a is minus 8, and if you divide through by a, you have minus 8. You divide through by 2, and the result is minus 4. Also, you have 3a plus b is 28, which is 3 into minus 4 plus b equals 28, which means that b is 28 plus 12, which means b is 30, 40. So we got that b is 40. Moreover, right, so moreover, if we have also a plus b plus c. So which means c equals what? So this is equal to 36. And then if you say 72, okay, minus 4 plus 40. Minus 4 plus 40 is 36. 72 minus 36 is also 36. What is then the result here? The result is therefore that Tn, remove and come to this. Tn is exactly an squared plus bn plus c. A is what? Minus 4, n squared plus 40, n plus 36. So which means Cn is minus 4n squared plus 40n plus 36. So these are the quadratic sequences. Right, in 2.1.2 now we're saying a term in this quadratic sequence with the term 72, 100, 120, 32 is equal to the 12th term of the sequence of first differences. Determine the position of this term in the... Yeah, who is that? Okay. Okay, I'm coming. Okay, just 1 minute. I need to open for somebody. Okay, you can be thinking about this question just for a split second when I get back. Okay, somebody's knocking at the door. Okay, we're right back now, and we continue with our discussion, and we look at this question. Right. So looking at this question, we have the following. Right. So we have, what do we get precisely? We have a term in the sequence, right? So a term in the quadratic sequence 72, 100, 120, 132 is equal to the 12th term of the sequence of first differences. Determine the position of these terms in the quadratic sequence. Right, and obviously, I'm saying the term in this sequence is equal to the 12th term of the sequence of first differences. You need to get the sequence of first differences. What is the sequence of first differences? Right, what is the sequence of the first differences? Sequence. Right, so the sequence of the first differences is what? Sequence of first differences. Right, so the sequence of first differences will therefore give us the following. Right, so these first differences, if you look at this here, the first differences are 28, 20, and 12. And the difference between these differences is -8, so which means that this is the common difference D. Okay, the implication is therefore that the common difference is -8 of the first differences. The first term of the first differences is what? The first term is 28. 28, 20, and 12. So the first term is 28. So Tn is A into this. What is A? Is 28 plus n minus 1 into the common difference minus that, which is 28 minus 8n plus 8. It's exactly 36 minus 8n. Okay, so for the first differences, we have the general term. -36 minus 8n. Right, so we're speaking about the 12th term. Right, so the a term in the quadratic sequence is equal to the 12th term there. Right, so the 12th term is going to be the same here, so we need to get term 12. 12th term is 36 minus 8 into 12, which is 36 minus, okay, can you get the difference? But clearly that difference is exactly, right, it is exactly the following. -60. Exactly -60. And therefore, we have n squared minus 10n minus 24 equals, no. Right, remember that what is the general term of this quadratic sequence? We got it before. Right, the general term of the quadratic sequence is the same as what? It is the same as exactly -4n squared plus 40n plus 60. So Tn is -4n squared -4n squared plus 40n plus 36. Okay, you'll tell me about your mom. Obviously, I mean, we are still here, and it might be about 11 when, yeah, I'm gonna spare 1 hour so you can do 1 hour, 1 hour, so you'll just let me there. Okay, but now This is the 12th term, but we're saying a term in the quadratic sequence is equal to the 12th term of the sequence of phase to determine the position of these terms, right? So we really are saying this 12th term, a term in the quadratic sequence, the term is Tn is equal to the 12th term. So which means it is minus 4n 40n squared plus 40n plus 36 is minus 60. So which means it is minus 4n squared plus 40n plus, if you bring this the 60, it's going to be positive, making it 96 equals 0. We can divide through by 4, negative 4, giving us n squared minus 10 n minus 24 equals 0. N and n. Right, the factors of these would therefore become minus 12 n plus 2. N is 12 or n is minus 2. Obviously, n cannot be minus 2 because it's the number of terms. So in other words, this one here is inadmissible. And therefore, the only result is n equals 12. So it is the 12th term that does this. Right, we need to determine right now the maximum value of the quadratic sequence. The maximum value of the quadratic sequence. What is the quadratic sequence? Right, so you consider the quadratic sequence 7200 and so on, 120, 132. Right, so we have the quadratic sequence. So it is exactly 72, 100, 120, 132, and so on. What is the maximum value of this quadratic sequence? The couple of things you already know about the quadratic sequence. You already know the Tn of this. We got it before. 2.1.1, we got that Tn was minus 4n squared plus 40n plus 36. Right, so we got that it was exactly minus 4 n squared plus 40n plus 36. Now we're going to get something else. We can find the derivative of this one, which is minus 8n plus 40. Is equal to 0 for the maximum. Which is minus 40 over this, which is what? 5. Fifth term. P5. Plus 36. And then now you get 136. Tn is 136. So T5. Right, because determine the maximum value. So the maximum value is occurs at n equals 5, and the maximum value is 136. If you don't want to use this one for the maximum value, in case the examiner asks for the maximum value, you can also use n equals minus b over 2a. What is b? It is exactly 40 over 2a, which is minus 4. Minus 40 over minus 8. 5. So for the maximum value, alternatively, you can use the n equals minus b over 2a formula. This formula obviously is what stands for the axis of symmetry. Okay, for the axis of symmetry, if you don't want to call it the axis of symmetry, call it the line of symmetry. And therefore, what is Tn? Right, substitute into the formula, and therefore you get minus 4n squared plus 40n plus 36, which is minus 4 into 5 squared plus 40 into 5 plus 36, which is 136. So Tn is 136. So you can use the derivative, this derivative we used here is a concept to use to find this here. And this concept to use to find this is for something we call the, it's called for calculus. You can use calculus. So you use the derivative. So this derivative is the first derivative of the function equals that, 0. Right, in 2.1.4, we're saying determine the maximum value of the sequence. Right, determine the maximum value of that sequence. 2.1.4. Right, so what is the maximum value of this sequence? Minus 23, 5, 25, minus 23, 5, 25, 37. We want to get its maximum value. First and foremost, we need to ask the question, what kind of a sequence is this one? Okay, it's given exactly 1 mark. You're given exactly 1 mark. Given exactly 1 mark, what would the maximum value of the sequence be? Okay, the couple of things obviously you need to consider here. And amongst these things are the nature of this sequence and how this sequence has been derived. Okay, it has been a modification from the terms. Okay, you look at how the question was set. You actually have the original sequence, which is exactly the one at the beginning, 72, 100, 120, and 32. Now they're asking for the maximum value of the sequence, this one here, which is minus 23, 5, 25, 37. Okay, what is happening with this sequence here? And also, how is it different from the preceding one? Right, obviously you can see that this sequence is vastly different from what we have been given. Moreover, what is then the connection between this sequence and the given one? Okay, a couple of things to note. Is it what kind of a sequence is this? Okay, 5 minus 23, 5 minus into minus 23. That will be 28. 25 minus 5, 20. 37 minus 25, 12. What is the difference here? 20 minus 8, 20 minus 28, you get minus 8. 12 minus 20, you get minus 8. Okay, so you really can see that this sequence is actually very, very similar to that sequence that is given there. Okay, it's very, very similar to the sequence that is given there. What must have happened here? If this one is the given sequence, how did the examiner get this one? It's like they might have, okay, I want us to study this because it's like they subtracted something. Okay, suppose the examiner took this one and subtracted 95. 95. If you subtract 95 from each term, so you start with 72, okay? That is his given sequence there. You start with 72, and then you have 72, you subtract 95. Okay, I'm just suggesting 95 because they had 100 here, and then now it has become just what? Just become 5. Right, so you subtract 95 there. You have 100, you subtract 95. 120, you subtract 95. 132, you subtract 95. So now you have what? Okay. So you'd have that it has been obviously obtained like this, and therefore now you have that. So you have that 72 minus 95, which is minus 23. 100 minus 95 is 5, which is what they got here. And then you have 120 minus 95. It's exactly 25. 132 minus 95. What is 132 minus 95? 37. Okay, so now what we are getting is the following: 23, 5, 25, 37. Okay, so the subtract is 95. So if now when you want to get the maximum value of this sequence, at what point because here from the previous question you were able to get the maximum value of the quadratic sequence. What did you get it to be in what 2.1.3? Right, you got the maximum value to be 136, and then you just must subtract from it 95. So in 2.1.4, you will say the maximum value is actually the maximum value of the quadratic sequence, but we're just subtracting 95 from each of the terms. So even from the maximum value, we're going to subtract 95. And if we subtract 95, we get the following. We get 41. So which means that this is what? 41. Okay, in 2.2 now we are continuing and we're looking at another sequence, but now this one is now trigonometric. And if you look at how the question was given, because here's the full question given by the examiner in this exam, right? This is a past exam question. In 2.2, now please you need to write down notes at the end of this question. Consider the sequence minus 11, 2 sine 3x 15. Determine the values of x in the interval 0 to 90 degrees for which the sequence will be arithmetic. Okay, what do we do? We're dealing with something called arithmetic, an arithmetic sequence. Okay, so the minute the examiner says arithmetic, so we have a common difference. So the common difference is going to occur T2 minus T1 equals T3 minus T2. Right, so T2 is 2 sine 3x minus, and T3, this is like T1, this is T2, and this is T3. So T2 therefore is 2 sine 3x minus T1 is that. T3 is 15 minus T2, which is 2 the sine of 3x. Right, so we just can deal with this. So it's exactly 2 sine 3x plus 11 is 15 minus 2 sine 3x. So which means therefore you have 4 the sine of 3x, which is 15 minus 11. Transpose 11 becomes negative. So you have 4 the sine of 3x equals, if you subtract this, you get 4. So you can divide through both sides by 4, which means it is 4 the sine of 3x divided by 4. You can divide the board. So in the end, therefore, you divide through by 4 and it becomes the sine of 3x is the number 1. You divide through by, okay, you take the result, but you're just between those here. So which means that you can take the arc sine. So which means 3x is the sine inverse. So you take the inverse function. So you take the inverse function of 1, and arcsine 1 is 90 degrees. You divide through by x, which means 3x is 90. Okay, which means it is 90 over 3, and 90 over 3 is 30. So x is 30 degrees. All right. And we know that actually 30 degrees actually occurs in the interval. Right, we know that 30 degrees occurs in that interval. Where does it occur? It occurs in that interval there. 30 degrees actually occurs into interval 0 to 90. Okay. So we have that. Now we continue and we're going to look at the next thing. All right, so we look at 3.1.
Mama, phone charge it.
All right. If R is 1/5 and A is 2000, determine the value of the general term of the series. Okay, this is an interesting question. The examiner does not even tell us the type of the series here. This is wrong, Mr. Examiner. Examiners, please don't do this. Okay, the examiner just assuming that we know that R is the constant ratio. But they must tell us. They need to tell us that we're dealing with a geometric sequence. And they don't say. So please, examiners, don't do this. Okay. Because now they're getting you off guard. Now they're just giving you R. What is R? Okay. But it is telling us that we're dealing with what? With an with a geometric progression. Right. So dealing with a geometric progression. So we're dealing with a GP. Right. We're dealing with a GP. And the GP is the geometric
Yes,
progression.
Elisa.
Yeah, you fine, Impo?
Yes.
Okay, thanks, Impo. Right, we're dealing with a GP, and the GP is the geometric. We're dealing with a geometric progression. So, dealing with a geometric progression, the examiners are naughty. Hey, examiners, please, once again, don't do this. The general term, therefore, Tn for the general term of the series. You see, okay, we're dealing with the geometric series. So, which means, therefore, we know that the general term is AR to the n minus 1. Tn is A, which means it's 1 over 5 to the n minus 1. So that's the answer. What is the general term? This is exactly the general term, and we're done for just 1 mark. Right, in the next question, we look at 3 that. So this one, we realized that from the previous question is actually Tn equals 2000 into that. So it is exactly 2000 into 1/5 of n minus 1 power. T7. So T7 is exactly 2000 into 1/5. 7 minus 1. Okay, so T7 is 16 over 125. So it allows us to find the seventh term. Obviously, we actually got it for the geometric series. Now, next question. Which term of the series will have the value this one. So we're looking at the term of the series that is going to have the value that. We remember that Tn for this series is actually 2000 into 1/5 to the power n minus 1, which term is equal to exactly 15,625. Okay. So this is exactly 2000. 1/5 n minus 1 is 16 out of 15,625. 15 n minus 1. Right, you reciprocate by the 2000 and then it becomes 1 over 195, 3125. Okay, you can divide the board like this. And then now it's 1/5 here. So we have 1/5 to the power n minus 1. So this is 1/5 raised to the power 9, which means n minus 1 is 9, which means n is 10. Okay, so this is what you get. N equals 10. Because you're saying which term of the series will have the value of this? Which term? 10th term. 10th term. Okay. We continue. Okay. Okay. Okay, continue. What is the next question? Consider the geometric right. So we have this one and we want to do this one. Consider a geometric series where Tn is that one. Calculate the value of the constant ratio. Calculate the value of the constant ratio. So now if you consider the geometric series where this is the case, so we have the infinite series, it's up to infinity from n equals 1 to infinity equals 27 of the Tn, the summation, and the sum of the first three terms of this geometric series is what? Is 26. Calculate the value of the constant ratio of the series. So in 3.2, you have the infinite series, 1 minus r. So this infinite series is equal to 27. So we know that the formula is a over 1 minus r, but we have been told that it is equal to 27. But the sum of the first three terms is what? Is exactly 26. So and this one we know Sn is a into 1 minus r to the power n divided by 1 minus r, and 1 is not r. So which means S3 is equal to the first term. The first term. We don't know what it is. So which means S3 is A into 1 minus R cubed divided by 1 minus R. But we know that S3 is 26. Okay. Clever question, Mr. Examiner. 1 minus R into 1 minus R cubed equals 26. So the 1 over the A over 1 minus R we know is this. So these are simultaneous equations. So you have equation 1 and then you have equation 2. And then what you're gonna do is you're gonna put or substitute third equation 1 into 2. So you have 27 into 1 minus R cubed. Which means 1 minus R cubed is equal to 26 over 27. Let's get the board divided, please. So now we proceed to solve this problem. If you have 1 minus R cubed, right? If you have 1 minus R cubed, yeah. What does this give us? Okay. Oops. Right, so you have this exactly. So you have the R cubed equals this. 1 minus R cubed is equal to 26 out of 27, which is 1 minus 26 out of 27 equals R cubed. So you subtract this one. So which is 1 out of 3. So which means R equals 1/3. R equals 1/3. You can write like this. The symmetry in the view. Symmetric 1/3 equals R is the same as R equals 1/3. So we have found the series here. Right, the next question is a very interesting one. It is based on these interesting things. Okay, advice me, Paul. We do 1 hour and then we split it. So you need to watch your situation. They advise me in terms of your movements. We can finish the lesson just after question 4, maybe just now. It's 11. It's like 7 minutes after 11. So it's about 1 hour. So you can advise me. You let me know. Okay.
Okay.
Okay. Thanks. Let me just do this question. Right. So now, if you have this question here, right, we have question 4. Question 4. The lines y equals x plus 1 and y equals minus x minus 7 are the axis of symmetry of the function. That one, show that p equals 4 and q equals minus 3 for the marks. 4.1 is the next question. Right, so we have the lines of symmetry, but now if you have the axis of symmetry, they intersect at the points. You have a graph like this, your rectangular parabola, and now you have that it's gonna, if the graph is like this, so it has some asymptotes here. One piece here and one piece there. So now you have that y equals x plus 1 and y equals minus x minus 7. Okay, these axes of symmetry will intersect at a point. Another one will be here and the other one will be there. So, which means, because obviously the A is negative here, so if the A is negative 2, it means that one piece is going to be in the second quadrant, one piece is going to be in the fourth quadrant. It's going to be in the even numbered quadrants, okay, because this is the second quadrant and this one is the fourth quadrant. Now, you can have another piece that maybe sits here and sits there when you have an equation that has a positive A over X plus P plus Q. Goodness me, we are happy. Solve simultaneously. Yay! Solve simultaneously, it means y equals y. If y equals y, the first y is x plus 1, and the next one is minus x minus 7. So you have therefore 2x equals minus 8. X equals minus 4. Which is minus 4 plus 1, which is minus 3. So which means they intersected at a common x value when x is minus 4 and y is minus 3. So, and this is going to give you a P, and this is going to give you a Q. So with that said, then we are in a position to write the following. So which means that now you have f of x is equal to minus 2 over x plus p plus q. Minus 2. Right, so you have x is minus 4. Maybe tricky this one, so you need to make sure that you watch your signs here. So here it means x is minus 4, y is 3 negative, so x plus 4 is 0, which means x plus 4 here. And then q is negative 3. Right, so obviously the understanding is therefore that p, so we've shown therefore that p is 4, q is minus what? Q is minus 3. Next one. Calculate the x-intercepts of f. Right, so we already know that p is 4, q is minus 3, so which means you can be able to write down the equation. Weapon 2 is minus 2 over x, p is 4, q is minus 3. Right. So we continue. What is the result here? What is the result here? Right, so we good. Okay, just one sec. Right, we need to just to deal with this one now and finish it off. But what are the results and what is the value of the x? And what are the x-intercepts of these here? What are the x-intercepts of these? So we're gonna find the x-intercepts out. How do you find the x-intercepts? So you let y be equal to 0 for the x-intercepts. Right, so let y be equal to 0 for the x-intercepts. Okay, if y is equal to 0 for the x-intercepts, it means we have 0. Which means it's x plus 4. Which means it's minus 3x minus 12. Minus 14. So which is 14 out of 3. Okay, check that one. Okay, minus. We minus that. Okay, you have minus this one. Right, so you have a minus 3. We have a minus 3 equals 14, and therefore you have a minus here. X equals minus 4 over 3. Right, if x equals minus 4 over 3, what is the x-intercept? So the x-intercept would be when x is minus 14 over 3, y is 0. Y is 0. So the x-intercept is minus 14 thirds and 0. The points. 2.3. Sketch the graph of f, clearly showing everything, the intercepts, the axis. Right, so we remember that the graph of f is minus 2 over x plus 4 minus 3. So you can sketch it like this. X-axis, y-axis. The asymptotes will occur at asymptotes they occur at the point where this denominator, you equate this denominator to 0. X equals minus 4, and then you have y equals minus 3. Y equals minus 3, x equals minus 4. Okay, now these are the asymptotes, and then what about the x? It's minus 14 over 3. 12. So it's going to cut somewhere here. Minus 14 over 3.
Yeah. Yummy.
Okay, you find them, Paul. So we go on like this.
Ma.
So you have that this one goes like this. And then
Okay, Mom.
this one is minus 3 here, and this one is going to cut here. So after this point, you're going to have the y-intercept. You must find it as well, because they must say, they're saying show all the intercepts. So to get the y-intercept, You let x be 0. So which means f of x is minus 2 over x plus 4 minus 3. F of 0 is minus 2 over 0 plus 4 minus 3, which is minus 2 over 4 minus 3, which is minus 1 over 2 minus 3, which is minus 7 over 3 over 2 minus 7 over 2. Right, minus 7 over 2 is the same as minus 3.5, terminating decimal. So it's going to cut here at minus 3.5, which is minus 7 over 2 still. So the graph is going to cut here. Right, so to sketch a graph, so you clearly label all intercepts with the axis and asymptotes. So you have these. Right, Impo, how are you doing time-wise? Can you take a break maybe so that you can do some chores? I don't know, it's up to you. I need to be advised by you, but I can take a break for 1 hour and then you can let me know then when you are back again.
Okay.
Yeah, okay, so we can do the next 1 hour when we're back again. I'm gonna send the recording in the next couple of minutes of this lesson, and then we can start again to do, because now we're gonna be starting another question. Okay, we're gonna be starting another question on more graphs and the things that come at the end of the exam. So you'll advise me then when you're back again, and then please we need to get back again for the next 1 hour when you are free, etc., etc. Okay.
No problem.
Okay, thanks, Paul. We'll chat then. Okay, thanks. Goodbye. I'll keep you posted of the lesson recording. Thank you. Goodbye.